Berlin, Germany, January 1943. 10:00 a.m. Adolf Hitler stands in a conference room at the Reich Chancellery, watching a film. On the screen, a sleek aircraft races across the sky. It has no propeller. Its engines are mounted under swept-back wings. It moves faster than anything the Luftwaffe has ever fielded. This is the Messerschmitt Me 262, the world's first operational jet fighter. It is faster than any Allied aircraft. It is more heavily armed, and it is nearly ready for production. Hitler watches in silence. Then he asks a question. Can it carry bombs? The engineers hesitate. The Me 262 was designed as an interceptor, they explain. Its purpose is to shoot down Allied bombers. It can carry a small bomb load, but doing so would compromise its speed and agility. It would be wasted as a bomber when it could dominate the skies as a fighter. Hitler dismisses their objections. He demands that the Me 262 be produced as a fast bomber, not a fighter. He believes that Germany needs offensive weapons to strike at Britain, to disrupt the Allied invasion, to turn the tide of the war. Interceptors are defensive, bombers are offensive, and Hitler, even in 1943, still believes Germany can win through attack. This decision delays the Me 262's deployment by over a year. By the time the jet finally enters combat as a fighter in late 1944, Allied air superiority is overwhelming. The Me 262 is a superior aircraft, but there are too few of them. They lack fuel, trained pilots are scarce, and Allied fighters swarm them during takeoff and landing. The Me 262 shoots down hundreds of Allied aircraft, but it cannot change the outcome of the war. This is what happened in our timeline. Germany developed revolutionary jet and rocket technology. The Me 262 jet fighter, the Arado R-234 jet bomber, the V-1 flying bomb, the V-2 ballistic missile, but it developed them too late, in too small numbers, and often for the wrong purposes. By the time these weapons reached the battlefield, Germany was already losing. They were technological marvels, but they were strategic failures. But what if Germany had made different choices? What if, instead of prioritizing thousands of conventional Messerschmitt Bf-109s and Focke-Wulf FW-190s, Germany had committed early to mass production of jets and rockets? What if Germany had recognized in 1940 or 1941 that the future of air warfare belonged to jet propulsion and ballistic missiles, and had redirected its entire aviation industry toward these technologies? Would it have changed the outcome of the war? Would Germany have achieved air superiority over Britain and the Soviet Union? Would the Allied bombing campaign have been stopped? Would D-Day have been prevented? Or would Germany simply have wasted resources on unproven technologies while losing the conventional air war? This is not a simple question, because technological superiority does not guarantee victory. Wars are won by logistics, production, strategy, and the ability to sustain operations over time. Germany's jets and rockets were impressive, but were they enough? Let us imagine what would have happened if Germany had prioritized jets and rockets over traditional aircraft during World War II. To understand this scenario, we must first understand Germany's actual development of jet and rocket technology during the war. Germany began researching jet propulsion in the 1930s. The theoretical work was done by physicists and engineers like Hans von Ohain, who developed the first working jet engine in 1937. By 1939, Germany had test-flown the Heinkel He 178, the world's first jet-powered aircraft. It was a proof of concept, not a combat aircraft, but it demonstrated that jet propulsion was feasible. The development of the Me 262 began in 1938. The aircraft was designed by Willy Messerschmitt as a high-speed interceptor. The first prototype flew in 1941, powered by piston engines because the jet engines were not yet ready. The first jet-powered flight occurred in July 1942. The aircraft was fast, over 540 mph, far faster than any Allied fighter. and heavily armed with 4 30mm cannons. But development was slow. The jet engines were unreliable. They overheated, failed frequently, and had a lifespan of only 10 to 25 hours before requiring replacement. The materials needed, heat-resistant alloys, were in short supply, and the aircraft itself was expensive and complex to manufacture. At the same time, Germany was developing the V weapons. The V-1, a cruise missile powered by a pulse jet engine, was simple and cheap to produce. It could be launched from ground ramps and carried a 1-ton warhead to targets in England. The V-2, designed by Wernher von Braun, was far more sophisticated. A liquid-fueled ballistic missile that reached the edge of space before descending on its target at supersonic speed. It was the world's first long-range guided missile, the ancestor of all modern rockets. Both the V-1 and V-2 were intended as terror weapons, designed to destroy British morale and force a negotiated peace. Production began in 1944. Over 10 000 V-1s and 3 000 V-2s were launched against Britain and later Belgium. They killed over 9 000 people and caused significant damage. But they did not change the strategic situation. Britain did not surrender. The Allied advance continued. In our timeline, Germany's advanced weapons arrived too late and in too small numbers. The Me-262 did not enter mass production until 1944. Only about 1/400 were built, and fewer than 300 saw combat. The V-weapons caused terror, but not strategic impact. And by the time these weapons were deployed, Germany was already collapsing under the weight of Allied bombing, Soviet offensives, and material shortages. But what if Germany had started earlier? What if in 1940, after the fall of France, Hitler had ordered the aviation industry to abandon conventional aircraft and focus exclusively on jets and rockets? Imagine that in the summer of 1940, after the defeat of France, Hitler convenes his top scientists and military leaders. He has just won the greatest victory in German history, but he faces a new challenge. Britain refuses to surrender, and an invasion across the English Channel seems impossible. Germany needs a way to force Britain to negotiate, and Hitler, advised by forward-thinking engineers like Wernher von Braun and Ernst Heinkel, decides to bet on revolutionary technology. He issues a directive. Germany will prioritize the development and mass production of jet aircraft and ballistic missiles. Conventional aircraft production will be scaled back. Resources, steel, aluminum, skilled labor, research funding will be redirected to jets and rockets. The goal is to achieve overwhelming technological superiority in the air and to strike Britain with weapons it cannot defend against. This decision has immediate consequences. Germany's aviation industry, which in our timeline produced over 30,000 conventional fighters between 1940 and 1944, now shifts to jet production. The Me-262 program is accelerated. Engineers work around the clock to solve the engine reliability problems. New factories are built. Pilot training programs are expanded to teach jet combat tactics. At the same time, the V-2 program is expanded. Instead of being a sideshow, it becomes a central element of German strategy. Production facilities are built underground to protect them from Allied bombing. Thousands of V-2s are manufactured. Launch sites are positioned along the French coast, within range of London. By 1942, the first production Me-262s roll off the assembly lines. They are still expensive and complex, but the problems have been worked out. The engines are more reliable. The aircraft can be produced at a rate of several hundred per month. By the end of 1942, the Luftwaffe has over 500 jet fighters in operation. The impact on the air war is immediate and dramatic. In our timeline, the Allied bombing campaign against Germany escalated throughout 1942 and 1943. American bombers struck by day. British bombers by night. German cities were reduced to rubble, factories were destroyed, civilians died by the hundreds of thousands. But the bombing was costly for the Allies as well. German fighters and anti-aircraft guns shot down thousands of bombers. Casualties among Allied aircrews were staggering, but in this scenario, the Allied bombing campaign faces a new threat: German jet fighters that conventional Allied fighters cannot catch. In early 1942, the first Me-262s are deployed against Allied bomber formations. The results are devastating. The Me-262 is 100 millisiemens faster than the fastest Allied fighter, the P-51 Mustang, which has not yet been deployed. Allied bombers, lumbering B-17s and B-24s, are defenseless. The Me-262 can dive in at high speed, fire its 30mm cannons, and escape before Allied escort fighters can react. In the first month of operations, Me-262s shoot down over 200 Allied bombers. The loss rate becomes unsustainable. The Allies are forced to suspend daylight bombing raids over Germany. The strategic bombing campaign, which in our timeline crippled German industry and morale, is halted. Churchill and Roosevelt face a crisis. Without the ability to bomb Germany, the Allies cannot weaken German industry. Without weakening German industry, the ground war becomes far more difficult. The Allies must develop countermeasures. The United States accelerates its own jet fighter program. The P-80 Shooting Star, which in our timeline did not see combat until the final weeks of the war, is rushed into production. But the P-80 does not become operational until late 1943. For over a year, the Allies have no effective counter to the Me-262. During that year, Germany uses its air superiority to devastating effect. With the Allied bombing campaign suspended, German factories operate at full capacity. Production of tanks, artillery, and ammunition increases. The Luftwaffe, no longer forced to defend German cities, can concentrate on offensive operations. In the east, German air superiority slows the Soviet advance. The Red Army, which historically relied on massive artillery and tank concentrations, finds its forces disrupted by German jet attacks. Me-262s strike Soviet supply lines, railheads, and troop concentrations. The Soviet advance, which in our timeline reached Warsaw by 1944, is delayed. In the West, preparations for D-Day become far more complicated. The Allies are planning to invade France in June 1944, but the invasion depends on air superiority. Allied aircraft must control the skies over Normandy to support the landings and prevent German reinforcements from reaching the beaches. But in this scenario, air superiority is not guaranteed. German Me-262s are stationed in France. They are faster than anything the Allies can field. If the Luftwaffe can contest control of the air over Normandy, the invasion could fail. Eisenhower, the supreme Allied commander, faces an agonizing decision. Does he proceed with the invasion, knowing that the Luftwaffe could disrupt it? Or does he delay, waiting until the Allies can achieve technological parity? He decides to proceed, but he knows the risks are far higher than in our timeline. On June 6, 1944, the Allied invasion begins, and within hours Me-262s appear over the beaches. The attack on D-Day is devastating. Me-262s strafe the landing beaches, destroying landing craft and supply ships. Allied fighters try to intercept, but they are too slow. The jets escape before the Allies can react, but the Allies have overwhelming numbers. For every Me-262, there are 50 Allied aircraft. The Germans can disrupt the landings, but they cannot stop them. By sheer weight of numbers, the Allies establish a foothold in Normandy. But the breakout from Normandy is delayed. In our timeline, the Allies broke out of the Normandy hedgerows in late July and raced across France, liberating Paris by August. In this scenario, the breakout is slower. German jet attacks disrupt Allied supply lines. The advance stalls. By September 1944, the Allies have advanced only as far as the Seine. Paris is still in German hands. The war, which seemed on the verge of ending in our timeline, drags on. At the same time, Germany's V2 program is achieving its objectives. Thousands of V2s have been launched against London, Antwerp, and other Allied targets. The missiles cannot be intercepted. They strike without warning. Casualties are in the tens of thousands. British morale is shaken. Churchill faces calls to negotiate. Some members of his government argue that continuing the war is futile, that Germany's technological superiority makes victory impossible. Churchill refuses, but the pressure is immense. In the United States, public opinion begins to turn. Casualties are mounting. The war, which Americans were told would be over by Christmas 1944, shows no sign of ending. Truman, who became president in April 1945 after Roosevelt's death, faces growing calls to seek a negotiated peace. By mid-1945, the strategic situation has reached a stalemate. The Allies have landed in France, but they cannot advance. The Red Army has reached Poland, but it cannot break through German defenses. German air superiority, sustained by mass-produced jets, has stabilized the front. And then, in July 1945, everything changes. The Manhattan Project succeeds. The atomic bomb is ready. Truman faces the decision of whether to use it. In our timeline, the bomb was dropped on Japan, but in this scenario, Germany is still fighting. Germany still controls most of Europe, and Germany's technological edge is making conventional victory difficult. Truman decides to use the bomb against Germany. On August 6, 1945, a B-29 bomber, escorted by long-range P-51s and the first operational P-80 jets, penetrates German airspace. The target is Berlin. The bomb is dropped. The city is obliterated. Over 100,000 people are killed instantly. The Reich Chancellery is destroyed. The government is decapitated. Germany is in chaos. Truman issues an ultimatum: surrender, or more cities will be destroyed. The German military, recognizing that continued resistance is futile, overthrows the remnants of the Nazi government and surrenders unconditionally. The war in Europe ends in August 1945, 3 months later than in our timeline. So what if Germany had prioritized jets and rockets over traditional aircraft during World War II? In the short term, it would have caused significant disruption to the Allied war effort. The strategic bombing campaign would have been suspended. The invasion of France would have been more difficult. The war would have lasted longer. But in the long term, it would not have changed the outcome, because Germany's fundamental problems were not technological. They were strategic and logistical. First, Germany could not outproduce the Allies. Even if Germany built 5 WWII 262s, the United States could build 50 Zone P-80s. Even if Germany launched 10 Zone V2s, it could not force Britain to surrender. The Allies had greater industrial capacity, greater resources, and greater manpower. Technological superiority could delay defeat, but it could not prevent it. Second, Germany's jets and rockets required resources that Germany did not have. Jet engines required high-grade alloys, rare metals, and precision manufacturing. V2s required liquid oxygen, alcohol fuel, and complex guidance systems. Producing these weapons at scale would have diverted resources from tanks, artillery, and conventional aircraft. Germany might have had superior technology, but it would have had fewer weapons overall. Third, the Allies would have adapted. In our timeline, the Allies developed jet fighters, radar-guided anti-aircraft systems, and tactics to counter the Me-262. In this scenario, they would have done the same, only faster. The American industrial machine, once mobilized, was unstoppable. Within a year of facing German jets, the Allies would have fielded their own jets in larger numbers. Fourth, Germany's strategic position was hopeless by 1943. It was fighting a three-front war against the Soviet Union in the east, the Western Allies in the west, and the strategic bombing campaign from the air. No amount of technological innovation could change the fact that Germany was outnumbered, outproduced, and surrounded. And finally, the atomic bomb would have ended the war regardless. Once the Manhattan Project succeeded, Germany's technological edge became irrelevant. The Allies possessed a weapon that could destroy entire cities in an instant. No jet fighter, no rocket could defend against that. But this thought experiment reveals something important. Technology alone does not win wars. Strategy, logistics, production capacity, and leadership matter far more. Germany's jets and rockets were technological marvels. The Me-262 was the most advanced fighter of its era. The V-2 was the ancestor of the space program, but they were wasted on a regime that lacked the resources, the strategy, and the time to use them effectively. If Germany had prioritized jets and rockets from the beginning, it might have delayed Allied victory. It might have forced the Allies to develop countermeasures faster. It might have increased casualties on both sides, but it would not have changed the outcome. Because wars are not won by individual weapons, no matter how advanced. They are won by nations, by economies, by alliances, by the will to endure. Germany had superior technology, but it did not have a sustainable economy. It did not have reliable allies. It did not have the resources to fight the entire world. And so it lost. The lesson of Germany's jets and rockets is not that technology is unimportant. It is that technology is not enough. A nation can build the most advanced weapons in the world, but if it lacks the industrial base to produce them at scale, the strategic vision to use them effectively, and the resources to sustain a long war, those weapons will fail. Germany learned that lesson in 1945. The Me-262, for all its speed and firepower, could not stop the Red Army from reaching Berlin. The V-2, for all its sophistication, could not force Britain to surrender. And in the end, Germany was defeated not by inferior technology, but by superior numbers, superior resources, and superior strategy. Imagine if Germany had prioritized jets and rockets from the beginning. Imagine the disruption, the casualties, the delay in Allied victory. And then remember that it would not have mattered, because Germany was fighting a war it could not win. Not with conventional aircraft, not with jets, not with rockets, not with any weapon. The war was lost the moment Germany decided to fight the Soviet Union, the British Empire, and the United States simultaneously. No amount of technological innovation could change that fundamental strategic reality. Germany's jets and rockets were brilliant, but brilliance without wisdom is not enough to win a war.